Okay, so today the plan is to talk about plugins in Rust with WebAssembly. You've all probably heard bits and pieces about WebAssembly. Some of them might be right, some of them might be wrong. It's kind of a weird thing at the moment. So I like to put this slide in when I do Rust, any meetup, because then I can just say stupid shit. So my background, lots of Scala, largely Spark. I feel like when Spark dies, Scala will die with it, is probably my gut feeling there. In fact, Databricks, who wrote Spark, sort of sneaked off and wrote it again in C++, which was a second mistake. But you know, when you're running these jobs, big data stuff, the JVM starts to kill you pretty quickly. When you're allocating half a terabyte of RAM on startup and you're waiting and this bloody thing is, you know, you've been there. Well, probably a few of you have. And then you've got the language itself, which comes with a lot of opinions. And it's so flexible or scalable that you tend to get a lot of different ways of doing the same thing, and you just drown after a while. And so I guess I sort of rage quit after a while and went to Go as my antidote, because it's so much simpler, and there's, you know, like, the tooling of Go is really an excellent thing. You know, like an opinionated formatter, love it or hate it, it solves a lot of opinions. All the stuff that comes with Go is good. Standard library's pretty amazing. At first, when I started with Rust, I was thinking, oh shit, maybe they've made a mistake here by not having a really, really powerful standard library like Go. Over time, I'm starting to think that's not correct, given the quality of what we're seeing, like Tokyo, you know, Crossbeam, all these very, very high quality crates are basically standard lib at this stage. And I hope we can kind of, I know it's probably not very nice, but we kind of redirect effort towards those rather than trying to re-implement Tokyo again for some minor benefit. But then I got pissed off at Go because, you know, like writing for loops with an index is just not fun. Like, I bugger it up every time. I don't want to spend even a minor bit of my brain thinking about how to write a for loop. When I've got nice iterators that the guy who's working for me that sort of is quite new to Rust, he's like, why are you always iterating on everything? But once you've got them, they're a very, very beautiful way of writing code, I think. I wrote this a few weeks ago. I wrote sensible middle ground, but that sounds pretty weak. I actually really, really rate Rust, and definitely it is the go for me. So I work at a company called Visual Cortex. We're trying to deploy computer vision because there's a lot of people out there writing a lot of Python. Who's tried to deploy Python? And who's tried to manage Python at scale? It is a disaster waiting to happen. I'm not interested in running anything in production at scale. We're talking enterprise type deliveries. Writing Python and expecting things to work for very long is not something I'm interested in. You're just waiting until the foot gun, something will come and get you in production. So we're doing a lot of work with GStreamer. The bloke who works for Collabora, I don't know how you say it, he wrote some Rust bindings to this basically C code base, and he's done an amazing job. He's paid to work on this stuff full time, and he's written this excellent plugins for Rust. GStreamer's been around for 20 years. Basically, it's like a pipelining tool for doing multimedia kind of stuff, largely video, and you're sort of thinking in buffers that go down a pipeline and you do stuff to them. So like transformations, and one of those transformations could be machine learning, which is what we do. But we're getting to a point where we pretty much need to be flogging our GPUs full time. So we're largely NVIDIA because there's no competitor in reality at the moment. There will be. But we're getting to the point where we need to start being more clever and sort of building dynamic pipelines at runtime. And that's why we're starting to look at scripting languages in there to give a little bit more control And this is really not so much engineering as much as company politicking, because if I don't have to maintain it and someone else can deploy code dynamically, that's quite a good benefit for me personally. And I don't need to go and compile things all the time for very minor changes. So we're talking WebAssembly. There's lots of options here. Basically, we want to run some sort of sandbox because we are going to support arbitrary code. Probably Python people would just run it and it'd be all good. We're not going to be those people. We want a sandbox, meaning like, you know, we need boundaries. WebAssembly is kind of, I'm going to say it, the new Java or JVM. But we're now in 2023, Java came out in, shit, who knows, like the 90s. So when you hear WebAssembly, the biggest problem is that they've put this word web in, and it's really not the right name for this thing. It's really just a portable assembly dialect that people are agreeing upon. So one of the platforms you could run WebAssembly on is your Chrome browser, because it supports it and it will execute it. We also have, because most of these people are in the Rust community, are writing this thing called WASM time. And it's really, really high quality. You'll see the guys in there, you see their names, and then you start looking around at all these other crates and they pop up everywhere. They're writing really, really good stuff, and it's basically become the reference implementation of WebAssembly virtual machine, or you know, this sandbox. And we're lucky because we write Rust, we can quite easily compile to WebAssembly through LLVM. So there's a few other languages that have sort of come and go, but I think Rust is probably the pick of the languages for writing and compiling to WebAssembly. So what we're looking for, we've got a way of executing this arbitrary code if we want, but I need something to be able to interpret arbitrary code. And in this case, there's something called QuickJS, which was written by, I don't know his name, Fabrice Bellard, the guy who wrote pretty much everything. QEMU, he wrote FFmpeg, like, I don't know, he sits down on a weekend and writes a full JavaScript interpreter or something, I don't know, he's elite. But for 1.2 megabytes, you can compile WebAssembly version of QuickJS, which means you can easily implement it into your code, and you can start to interpret JavaScript in a very, very safe little sandbox, which is exactly what we need. 1.2 meg, we just do include bytes, we bundle it into the binary and execute it. So you can see there's a tiny little bit of code. Shopify have done a lot of work here. Shopify are actually using this same mechanism for their plugin system for devs. I don't know really anything about Shopify. I don't know what they do with plugins, but they need arbitrary code execution and they're using this sort of approach. So you can see that they've created this package called QuickJS WASM that will compile QuickJS. There's a bit of plumbing code here to get your actual arbitrary code into the VM or that instance. And you can see I'm basically executing some code in a global context, which sounds terrifying, but who cares in a sandbox? And we return an output back to the program. Cool, so I was interested to see like how fast is this, especially coming from a JVM startup world where you can sit for a very long time. So I took some data points from a running watch that went around Centennial, and there's about 260 of these kind of things. This is a pretty made up example, but whatever, about 100 kilobytes or something. And then I went and found some code, because I don't know JavaScript, that does distance and then reduces it, so we could sort of imagine, like, I don't know, I don't care what you want to write, I want to make sure that it executes well. So there's some JavaScript, it's probably very bad. So, benchmarking. We've got criterion, if everyone's tried benchmarking in Rust, very, very good. And you can see, basically I was passing in a string with 100 kilobytes of JSON at the top as a string. Those functions at the bottom and something to invoke them. And you can see that the performance is kind of horrible. 8 milliseconds is a very long time. But there's sort of ways that we can get things a bit better. And maybe 100 kilobytes is a very unrealistic case, but I'd prefer to go big for benchmarking, and then we can sort of rationalize what's going on. So there's a thing called WASM. You can imagine that when you spawn one of these instances of the WebAssembly runtime, it's basically just a memory allocation. You know, it's doing everything within a controlled memory space. That means you can snapshot that memory and rehydrate it, you know, for next time. And that's what this thing called WASM has done. It's also by the same guys that did WASM time. So you can imagine if I was to spawn a JavaScript interpreter, there's probably some stuff that happens when it's getting set up. I don't know, like registering globals and stuff. So WASM allows us to instantiate QuickJS at compile time, then snapshot the VM. And you can see that by doing that, the runtime went from about 8.3 milliseconds down a little bit, down to about 8.1. So it's worth doing because it's kind of free performance and you don't really have to do anything for it. Then we look at what's happening with Shopify. Basically, what they've done is they've built with this thing called JV, which is the name of this plugin thing. They've built a way to basically compile in the function that you've given into that same instantiation cost. Because you can imagine it might take a little bit of time to interpret that JavaScript string and make sure it's valid and do stuff like that. But it's bizarre because they've put a lot of effort into this tool chain and basically it's unmeasurable, or, you know, very, very tiny benefit. But it comes with a massive downside. Now they have to ship all of these WebAssembly files around, which are single purpose, rather than a generic interpreter. Maybe if you're Shopify, that's totally worth it. Not really for us, because our GPUs are always the bottleneck, and saving maybe 0.1 of a millisecond is not worth the time. But I think the performance still sucks. So we can go a bit deeper into actually what's happening. So what I did is I took all of those functions, that whole JavaScript thing, chucked it into WASM at compile time, and then instantiated it and ran it 1,000 times or something. And you can see it's not slow. So we actually have now like this capability to spawn a VM, a sandboxed environment with an interpreter, and it's responding in under a millisecond. Like, yes, it's very slow for what it's doing, but the organizational benefit of me not having to manage compilation of 1 million, you know, like small functions that people want, plus I don't know what you're going to want, I think that's pretty good. So what we can see there is the parser is the slow bit here. It's not that the execution time is particularly slow, it's trying to parse 100 kilobytes of JSON string. And clearly, Shopify worked this out as well. Because what they've done is inside that QuickJS WASM Rust crate is they've exposed a way of serializing more directly into the QuickJS environment. I think there's still quite a bit of opportunity here. But you can see, like with a very minor change, a different serializer, deserializing sort of pattern, we're getting, what's that, about a third of, or 2/3 benefit. For me, this is fine because it's slower than, it's faster than our slowest point of our pipeline, which is always going to be GPU for us. Maybe those numbers are good for you, I don't know. But remember, this is also 100 kilobytes. Like, how often are you going to do this in reality with the kind of functions you might want arbitrary execution of code for? And finally, because QuickJS is because the WebAssembly runtime, WASM time, is single-threaded, if your code is parallelizable, you can easily run it with Rayon, and you could run N-many in parallel. This is on a 16-core laptop, and you can see that it's getting reasonably respectable performance. So I guess there is a blog post that is basically exactly the same, and I just took the code back from there. There is a crate that's, well, it's not a crate, it's some code on GitHub that you could pull if you want that does the plumbing of getting data in and out. I guess questions? Yep.
Yeah, I'm working with WASM time right
Yep.
now, so I'm really interested in this. So the people who are writing the plugins are like your clients? Or
They will be, and also other people in our... Oh, sorry. Who's writing the plugins? Are they clients or someone else? The answer is they will be a combination of both our staff that probably aren't Rust really comfortable, but presumably you could run, a Rust plugin if you wanted. Mainly we're intending it for an end user, that can write a bit of JavaScript, and that's why we're picking a scripting language. You can also compile, as of just recently, the Python 3 something, whatever they're up to, does compile to WebAssembly as well. But you're looking at about 100 meg runtime. So it's a big fat thing.
But this can all be loaded up ahead of time.
It could.
Yeah,
Definitely. There's a lot of opportunity here.
Yeah, so there is not yet a way of compiling easily JavaScript directly to WebAssembly, the whole environment together. Yeah. I looked that up and I couldn't really find a good one either.
So the statement question was, can you really compile JavaScript? Not easily. So this tool set, you can compile bytecode for the QuickJS bytecode, which is going to be different to Chrome or whatever. Maybe that's enough for you. Everything's here.
No, I was thinking you could just compile JavaScript to WebAssembly.
Yeah, so there's a project called Assembly Script. I've tried, I just don't get it. I don't know. They don't seem to tell you the hello world. So I've bounced off it pretty hard. Plus, this not having to go through a CI step to deploy code is kind of appealing. We're buying an organizational problem or a customer problem more than an engineering problem. But we've got the tooling now, and I'm sure other people might have use cases for a sandbox that can execute arbitrary code pretty quickly.
What is the relationship between the JavaScript runtime and the Rust? Does it just instrument the Rust to do some work, or does it do actual work in the JavaScript?
So it's kind of the other way around. So that crate... Oh, sorry. I've forgotten the question.
The relationship between them, which one does the work?
Yeah, okay, the relationship between Rust and the QuickJS runtime. So QuickJS is, I think it's a single C file. I'm not sure if it's bigger than that. That QuickJS crate will compile the C code plus the Rust wrapper code. So you're pretty much just passing through. It's doing a very minimal bit of Rust code. Pretty much that plumbing. How do you get data to and from, and how do you want to protect it? Does that kind of answer?
So a bit higher for your product. Do you need an entry for data scientists to be able to instrument the Rust core?
So when we're talking GStreamer, we've written a lot of plugins. One of them will take an arbitrary code and it will orchestrate all of that so that we're passing in a specific shape of data that we need, and it will then apply a function to it and return data that we can then continue down the pipeline. I can talk to you later. I think I've missed the point.
Maybe the question he brings up in my mind is so is the host who's running the
Yep.
test JavaScript, is the communication happening in your application between those two?
Oh, okay.
Or are they just one, it just runs and the output comes out? Or is there
Yeah.
quite a lot of back and forth?
So maybe something I did make very clear is, and this is going to sound crazy, we're instantiating a new virtual machine or WASM instance every time, every execution. There's actually a hard-coded limit in WASM time of 10,000 executions before it says no, because they haven't implemented a whole lot of garbage collection and all sorts of stuff. So that code there is pretty much what it's doing. Get string, run string, get result, ship it back. Yep, and what I'm doing in that crate is taking care of some of the plumbing to get that data in, because you've got kind of two options. You've got a linear memory space that you can access from the host if you want to, and you can expose basically a function inside the container that allows me to say, get data from Rust and push it back to Rust. Rust is actually getting a raw pointer from the VM and a length and reading the raw bytes out of that instance and pulling it back.
How much unsafe have you used?
There is unsafe because we're talking linear memory inside basically a sandbox.
But there's no width. Like
Yeah.
yeah.
But I think they're doing unsafe. You just don't see it.
Hey.
Yeah.